Hello there, Mr. Sutton here, bringing you the IM374 Extra Practice number 5 solutions on applications of right triangle trigonometry. There's a puzzle that goes with this one. Let's take a look at that. So here's the puzzle that goes with this extra practice. In this one, we have a whole bunch of triangles here and a few word problems down here as well. We have to find the angle indicated in each triangle, for example, A, B, and C, and whatever that angle is, we have to find it over in the answer column over here on the right, and then whatever word that is, write that next to that letter in the boxes above. So for example, if I do problem A right here, and I figure out that angle A has a measure of, say, 57, then I would put the word phys in box A. Now I don't think that's the actual answer, but just as an example. So let's go ahead and see how this goes. For our first problem, we've got this triangle right here, triangle with the angle A. So I've written the word SOHCAHTOA, and I'm just going to keep that written for this entire puzzle because all these problems are right triangle trig kind of problems where you basically have to figure out whether you have the opposite, adjacent, or hypotenuse sides and then use the correct trig ratio to figure out the angle. In this one, for example, we have the side that's across from the angle, so the opposite side. We also have the hypotenuse. So that would be sine equals opposite over hypotenuse. And then that's the sine of A equaling 9 over 16. Sine of A opposite over hypotenuse. Now to actually figure this out, I'm going to have to do sine inverse of 9 over 16. And for that, I have to go to my calculator. So here I am on the calculator. I'm going to first, at the very beginning of this puzzle, go to mode and make sure that I'm in degrees mode, because that's what all the answers are in here. Now looking at my settings, it looks like I'm in radians mode, not degrees. So let me scroll down, arrow over, and press enter to get that into degrees mode, and then quit out of there. Now to get these inverse trig functions, you have to press the second button and then the trig function, so second sine. At least that's how it works on this calculator. Might be different on the one you're using. And then we can just do 9 divided by 16, and close the parentheses is optional here. Press enter, and that gives us 34.2, so just 34 degrees. They said nearest degree. And for 34 degrees, just finding that over my answers here, that's right here, that's the word the, so that's going in spot A. For problem B, in this triangle, we have the opposite side and the hypotenuse. So we've got sine again, opposite over hypotenuse. In this case, we have sine of B equals opposite side of 5.8 over hypotenuse 7.2. So then we're going to do sine inverse of 5.8 over 7.2 in order to find the answer. And I'll use my calculator for that. So again, to do the inverse trig, you have to do second and then the trig function, the original trig function, and this works for cosine and tan as well. So sine inverse of all that is going to give me about 54 degrees if I round that off. So 54 degrees, and it looks like I've got that right here. This is soda going in spot B. This time around, based on my angle, I have the opposite side and then the adjacent side, the side that's part of the angle but not the hypotenuse. So opposite adjacent, that's TOA, that's tangent, equals opposite over adjacent. So we have tan of C equals opposite side 40 over adjacent side 94. So then I can do tan inverse of 40 over 94 in order to get my angle. And then running that on the calculator using second tan, that ends up being about 23 degrees. 23 degrees is right up here. That's bottle. So that's going in spot C. For this problem, we have the adjacent side, the non-hypotenuse angle, part of the angle. And then we also have the hypotenuse. So adjacent hypotenuse, that's ca. Cosine equals adjacent over hypotenuse. We have cosine of D equaling adjacent side 8 over hypotenuse 12. So then D is the inverse cosine of 8 over 12. Inverse cosine of 8 over 12 on the calculator, that's second cosine. That's going to give me 48 degrees. And then 48 degrees is going to be, which of these words here? We got to take a look. There's a lot of them. There we go. That is the word. On this one, we have an angle that's up here now, so the position's changed a little bit. Based off this angle, we have the opposite side, the side across from it, and also the hypotenuse across from that right angle. Opposite hypotenuse, we have sine equals opposite over hypotenuse. So sine of E equals opposite side 23 over hypotenuse 25. And then E is going to be sine inverse of 23 over 25. So plugging that in, I end up with 67 degrees if I round that off. 67 degrees is going to be this one took. That's in E. For this problem now, F is all the way over here, so they really are wildly changing the position of the angles now. Based off of that, we have the side across from it, the opposite side. We also have the non-hypotenuse part of it, the adjacent side. So that's going to be TOA. Tan equals opposite over adjacent. So we have tan of F equaling opposite side 60 over adjacent 47. So tan inverse of 60 over 47 is going to give me my angle. And if I plug that in the calculator, that comes out to 52 degrees. So we've got 52 degrees, which matches up with music. So we've got the soda bottle that took music, and then we'll have to keep going. For this one, we have the adjacent side. It's the non-hypotenuse side that's touching the angle G here. We also do have the hypotenuse. Adjacent hypotenuse, that's cosine adjacent over hypotenuse. So cosine of G equals adjacent side 3.8 over hypotenuse 5.1. And I need cosine inverse of all that, 3.8 over 5.1. And if I plug that in, that's going to be about 42 degrees, the meaning of life right there. So 42, that's going to be lessons. For this problem, for H, we have the adjacent side, non-hypotenuse touching side, also the hypotenuse. So this one's a cosine adjacent over hypotenuse. We have cosine of H, adjacent side 70.7 over hypotenuse 100. So then cosine inverse of that stuff gives me my H. And plugging that in a calculator, we end up with 45 degrees. So right there, 45. That's going to be the word in. That's going in spot H. On this triangle, we have angle I. We have the opposite side from that, and also the adjacent non-hypotenuse side. So opposite adjacent, TOA, tan. That's opposite over adjacent. So tan of I equals opposite side 11 over adjacent side 22. So then I is tan inverse of 11 over 22. Plugging that in is going to give me 27, if I round that. 27 degrees. So 27 degrees matches up with order, so that's spot I. For angle J in this triangle, we have the adjacent side, the non-hypotenuse leg. We also do have the hypotenuse, so that's going to be cosine adjacent over hypotenuse. So cosine of J, we can say, equals adjacent side 90 over hypotenuse 263. So then J is cosine inverse of 90 over 263. Cosine inverse of all that gives me 70 if I round that off. 70 degrees is going to be corresponding with a 2 all the way down here, so TO for J. The next few problems are kind of word problems. You could just solve these by looking at the diagram and finding the angle that they want, but let's read the backstory here. So we have a wheelchair ramp rising 4.3 feet over a distance of 30 feet. We want to know the angle of the ramp with the horizontal. So we've got the opposite side and the adjacent side here. So that's going to be tangent. Tan of K equals opposite side 4.3 over adjacent side 30. And now let's do tan inverse of 4.3 over 30 to find angle K. Plugging that in, we end up with approximately 8 degrees. So that's the angle of that handicap ramp. And just looking at the word that goes with that in our puzzle here, 8 degrees matches up with become. So K is become. This next problem, L, is kind of tricky. We have a plane descending 1,000 feet while flying 1.8 miles. We want the angle of descent, that's this angle L here, and they're telling us a mile equals 5,280 feet. Interesting they would give us that. We'll see why they did. So first off, which trig function? We have the opposite side from L and the hypotenuse. So that's opposite over hypotenuse. We have sine of L equals opposite side 1,000. And before you write 1.8 miles, keep in mind that we need the same units in the numerator and denominator for the number we use to actually work out in the calculator. So let me figure out how many feet 1.8 miles is. I can do that by multiplying it by 5,280. So 1.8 times 5,280 on the calculator is coming out to 9,504. So that's what I'm putting in my denominator. So then I'm going to do sine inverse of 1,000 over 9,504. And if I plug that in and crunch those numbers on the calculator, I get an angle of 6 degrees, roughly. Now 6 degrees matches up with the word A. It kind of seems lame for all the work it took us to get there, but hey, there it is. For this next problem, we have the top of an 18-foot water slide being 14 feet above the ground. We want the angle that the slide here makes with the ladder. All right, so let me see here. With SOHCAHTOA, I have the hypotenuse, and I also have the adjacent side, the non-opposite side here. So adjacent hypotenuse, that's cosine equals adjacent over hypotenuse. So in this case, we can say cosine of angle M equals my adjacent side 14 over the hypotenuse of 18, and then M is going to be the inverse cosine of 14 over 18. All right, calculator time. So inverse cosine of 14 over 18, that's giving me 38.9, so we'll round that off to 39 degrees. And then 39 degrees, I see it actually right here, this is band, so we'll put that under M. And so we finally come to the last problem, problem N. So now we're tracking a rocket launch. We want to know the angle that a camera at point N has to be aimed to photograph a rocket here at point O. And we're shown that we have a 3-kilometer distance between the camera and the point from which the rocket took off. And we also know the rocket has gone 5 kilometers into the air since that time, which I'm sure they have all sorts of instruments that can measure this stuff. So, which one are we using here? We have the opposite side and the adjacent side, not the hypotenuse. So we've got TOA, tan equals opposite over adjacent. We have tan of angle N equaling opposite side 5 over adjacent side 3. So then N itself is going to be inverse tan of 5 over 3. And then tan inverse of 5 over 3 on the calculator comes out to 59 degrees, roughly. And then 59, let's see where that is. That looks right there, liter. That's going in spot N. So at the end of this one, we've got all the words in there. Remember, this was one of those did you hear about puzzles. So here they have, did you hear about the soda bottle that took music lessons in order to become a band leader? Oh, okay, like a liter of soda. Very nice. Till next time, Mr. Sutton signing off.